So today we are going to be finding the derivative using two ways, of which one is using first principle. Remember, never ever use first principle unless you are told so. Today we are going to be finding the derivative using two ways, of which one of them is first principle and the normal way. And remember, only use first principle if you are told to do so. And normally in my experience, when you are required to use first principles, the marks will be around 6 or 7 marks. But if you are required to use the normal way, marks are normally around 3 there. Whenever we speak about derivative, you must think about associating with gradient. So remember how we use changing y over changing x for 2 points. When deriving, we try to narrow down the value of h. Okay, what you should note is that derivative is like finding a gradient. So whenever we speak about derivative, think of gradient associated. Remember how we used to find a gradient given 2 points using the formula changing y over changing x. Well, now imagine if you are required to find a gradient on a tangent. Remember, a tangent from circle geometry, we know that it's a line that only touches the circle once. Tangent is that line that cuts a graph at only 1 point. And then for those who don't know, we have a line that touches a graph at 2 points, known as a secant. This is the line I am talking about. So when we derive, we try to narrow the value of h from this formula here. This is the formula for finding the gradient of a tangent given 1 point. So this is how the formula is. And then when we're deriving it, it brings us here. The gradient is equal to f of x plus h, of which is the value of which is this here. Let me show you. This is the f of x I'm speaking about. So this is the value of x here. So this is the f of x plus h minus f of x. This is the formula. And then when we simplify this formula, you know this x will cancel this x. You can see here, it will bring us here. So when we simplify this formula, gradient is equal to f of x plus h minus f of x over x plus h minus 1. So this is a given formula. You always find this on your formula sheet. When we use this formula to find a gradient, we are deriving. Derivative is literally using this formula to find the gradient of a tangent given 1 point. One thing you should note is that if you are told to apply first principle, make sure that this lim as h tend to 0, you apply it further down up until where you remove this h here. So there are rules and ways on how to get to this step. So this is what we are going to be doing in this video. So it might sound complicated, but don't worry. This is what we are going to be doing in this video. I'm going to show you where and how to drop this lim as h tend to 0